And good evening, everybody. Welcome back into the Dragon's Den. My name's Digital Dragon, otherwise known as Luke. I'm a 3D printing variety streamer here on Twitch. Seeing this over on YouTube, I do most of my streams over on Twitch, but I will be doing some content over on YouTube here very short. Welcome on in. When I say a 3D printing variety streamer, well, what does that mean? It means we do everything from unboxings like our X1C carbons here to full up printer builds like some of the Vorons that you see behind me. We even do a little bit of prototyping like the Zero G Mercury 1 full machine build here. We've got some Fadus conch nozzles in the X1Cs that were done under a closed beta. So yeah, a lot of fun stuff here on the channel. We do a few of these things like helmets, armor sets, and blasters too from time. So welcome on in, everybody. I see Cruising Girl, Chewy, Royal Nomi, Mr. Wizix, Zombie. Hey, Zombie, how's it going? How goes the black box build? Hopefully doing good. And yeah, Royal Nomi, it's great that the doctor yelled at you. Now, my question is, are you on a monitor and did the doctor call you to yell at you because of things on a monitor? Or did he just call you up and yell at you during a standard appointment? I would say that's the best way to do the black box. For those of you that are interested in what we're talking about, so this is the black box over here. It is a 5-head tool changer. This one's, I actually need to get it going again for some prints that are coming up. So I need to get it plugged in and get some stuff squared away on it. It hasn't run since we went to the last show, which was 3D Printopia. I just need to get it back online, revalidate a few things, and get it going again. But yeah, great printer. Also a great printer. This is the RatRig VCore 400, or excuse me, 300. RatRig VCore 4 300 with the hybrid setup. I'm waiting for shipment of the IDEX toolhead on here, and we'll do the IDEX build out on this one, which will give us another set of capabilities for this particular printer here. And yes, that is a box turtle sitting up there with a box turtle on top of it. But yeah, I hope everybody's doing well. Hey, Print and Play Kilo's Way, welcome on in. Glad to see you here. Hope you're doing well. You uploaded to patient portal your heart app results, and then he called you and said, "Excuse me, young lady, but what are you doing?" Welcome in, Eagle the Dragon. We're doing good. Mrs. Dragon is on the way back home. She went and did the standard run, so I will be having some Dunkin' delivered here shortly. Pretty much y'all could be twins. Exactly. See, I know that. I know how those things go. So where are we at? Well, you kind of got a little bit of a preview, so we'll do a couple of different screen switches out here right now. Oh, nice. So here is a nice side view of our LH Stinger. It's kind of hard to see with this particular view, but it is a bed slinger. So this is our main frame. Our Y-axis is going here. These are the big fans, the skirt cooling fans on the back side. And when I say big fans, I mean the two 50-15 part cooling fans. You can stick them together and stick them inside the mouth of these. These are 97-33 blower fans. Pretty big and crazy. And then over here is our electronics box. So I'll go ahead and bring up the overhead view. It'll give a slightly different view of it. So once again, this is our main gantry. It's all 30-30, 30-60, and then 30-90 at the base. The Y is 30-90 as well with dual Y motors, a single Z motor, or excuse me, single X motor, dual Z motors. So we've got belted Z on each side, makes it a little bit faster. The tool head is a Dragon Ultra High Flow with a all metal Sherpa mini extruder. Electronics wise over here, we've got both a 24 volt and a 48 volt motor, or excuse me, power supply. The X and Y motors are running on a 5160 stepper driver at 48 volts. Z and everything else is running 24 volts. We've got a Raspberry Pi 4 in the, I think it was a 4, maybe it was a 5. Raspberry Pi. Yeah, Raspberry Pi 5, or excuse me, 4. Raspberry Pi 4B, jeez. In here, and the main board is a spider board from FiSet. This is a full FiSet kit. This is a carbon fiber bed, and right now there's nothing on it, just straight carbon fiber. They do provide a PEI sheet, PEI sheet that you can put on there. And they also provide a roll of Kapton tape. Now, for those of you that don't know, you can take Kapton tape, put it on your bed, and print directly on Kapton tape. In fact, this is how they used to do it back in the old days, back at the beginning of 3D printing. So I don't know, we may print directly on the bed today because I do plan on pushing plastic through this. Where we left off on the last stream, we had, let's see, we had verified movement, we had verified our end stops and the docking probe. I just wasn't getting the docking probe picked up. And I just realized in this orientation of the printer, you're not going to see that. So let me turn this back around. When we go to print, I do want it like this because all 4 edges, so the 4 Y feet and the side feet are on this solid surface. So I definitely want to print with it this way. But what I'm going to do right now is turn this back around so you guys will be able to see. And when I do this, the uprights are barely on, like 5-6 millimeters of the upright foot, air quotes, is on the bench here. So, but this way you'll be able to see things a little bit more. Right now, the probe is docked. I'm going to, or excuse me, the probe was on. I'm going to go ahead and put the probe back over here. And I think for this, the bench side will be a little bit better of a view. Hey, there we go. So what I'm going to do is just go through and do a homing sequence. Let me do this so you can see what I'm clicking on down here. Let me do this and hope that it'd be great if one day it was looking, you know, it was already at the right thing. So we've got our web interface down here in the bottom right-hand corner. And a couple of things I did off stream, right, was one, this has the LH Stinger theme applied to Mainsail. It's one of the folders. You just download the folder, upload the folder and contents, and bada bing, bada boom, you get their nice theme. One of the nice things with their themes is if you come down here, they've got all of their macros broken out into filament, force moves, clipper stuff. So max fan, Q mode exit, motion stuff. So this is primarily your quick draw home tilt. So it'll be a homing and a tilting procedure, quick dock attach, dock, latch, mesh, Z offset, etc. You have parking commands that will move the tool head into specific places. and then you have your resonance testing macros set up. This is kind of nice. They're all different colors and all that. So it's pretty neat little setup there. So what we're going to do is we can either do a home all or we can do a Z tilt, or home all and then a Z tilt, or we can scroll down here and do the full quick draw home tilt. Now the only difference is, well, actually, this just does it all in one. So let's go through that process. I'm going to click on that. It's going to home the axes. It'll drop down and pick up the probe. It'll go over, probe at the middle of the bed. And then it's going to do the Z tilt, or excuse me, the X gantry tilt. And this is setting up the gantry level with the bed at these 2 points. And then it comes back and does a home. Now you notice it kept the dock on there. That's the only thing that, hey Lee Marie, how's it going? Yeah, it's the LH Stinger. So what is the issue with the probe? Nothing really is the issue with the probe, other than the fact that it just went and did the homing, it did the Z-tilt adjust, it did another home, and it did not dock that probe again. Which means if I try and do a print right now, it's going to drive that in. That's the only thing that I have with running that particular macro. I don't know if it's dock or I think it would be dock, because attach would be to pick it up, dock would be to put it back. I have no idea what latch would be. And I will tell you, getting that right there was a major pain in the butt. And really, it's getting it the right distance forward, the right distance, side to side, and then also the height. They have all of those adjustments that you have to make to be able to get it to pick up successfully and repeatedly, right? Without catching, hanging, or whatnot. So I spent a while up here just trying to get that docking sequence working well. Does Kapton tape offer any advantages to PEI BuildTac PEO? It's pretty cheap for a roll, and it's fairly easy to apply and then take back off. PEI, like this PEI sheet here, it's got a 3M backing on it that is very heat resistant, and it's a pain in the butt to get off. I put PE or Kapton tape on a few things, which is very heat resistant as well, but it is a little bit easier to get off normally and replace. Oh yeah, cool, not a problem, Lee Marie. I may jump over to your stream afterwards. Is it who's streaming tonight? Is it Hila or are you guys streaming? It's Tuesday night. You guys are streaming on YouTube, right? Hey Rittenhouse, how's it going? Yeah, Kapton tape is, so I've used Kapton tape as an insulating layer whenever you've got a board with pins that may be kind of close to metal to keep it from shorting out. I put a couple of layers of Kapton tape over the metal side so it doesn't have direct contact. We used to use them to wrap the heaters on hot ends, right? That was how they did it back in the day. Hey, the shrimp fodder, how's it going? I've used it for bed material. Now the PEI is a little bit thicker and it gives you a little bit more, I'll say, forgiveness if you're down too low. But oh yeah, oh yeah. If you've got some of these, you're golden. If you don't, and the nice thing is this is a stock bed. There's two different sizes. There's a 200 by 200 and a 235 by 235. A 200 is the same bed size that was on my TiVo Tarantula, which means I've got a couple, because I bought some before, I've got some additional PEI sheets that I can put on this. So sorry, what we're going to be looking at is we went through the all-wheel drive Y stepper motor sync. It's as good as I'm going to get it. I'm I'm not going to worry about tightening the belts up anymore just yet, because as we move it around, it's going to stretch and find its, it's going to stretch a little bit after we do a little bit of printing. So I want to print on this for a little bit, and then I will go through and retighten the belts. Whenever you retension the belt, especially the Y belt, you must go back and resync your motors. They're not going to stay in sync when you retighten that belt. So you need to retighten the belt, go through and resync the motors and all that. Oh yeah, this, like I said, this comes with a roll of Kapton tape, and it hasn't told me to use it anywhere. And I will tell you that there is a spot in the manual where it says to take and make small squares and put over the four screw holes on your bed when you're starting to do some of the procedures. I've noticed I haven't needed to do that yet, even running a bed mesh. But so we did the stepper sync, and we were going to get into heater calibration. So this can take a little bit. I will tell you, I ran the PID tunes already. I PID tuned the hot end. I PID tuned the bed. Okay. Yeah, it came with a roll and it came with a PEI sheet, and they specifically tell you not to put the PEI sheet on until you get your bed fully adjusted. Yeah. It was really exciting, Da Vinci. I basically sat here and I copied this command, right? I pasted it, hit go, and and just waited. That was the exciting part of it. You know what? You guys are sitting here seeing my belly, so how about if I just take a load off for a second, and that way you might be able to get to see my my handsome face. Nope, nope. There you go. I'll try and keep my forehead down. I need to put a hat on. You get between this glare and this glare, it washes everything out. The foot's doing good, Rittenhouse. Like the other day, I didn't think twice about it, and I just squatted down, which of course takes your foot and does that, and you get that crease because I'm wearing my hunting boots still because they're the most supportive. So it creased right over the top of that toe. It still hurt, but hey, Pez Liz, how's it going? Just made an evening coffee. There you go. There you go. And sang the same tune, Anticipation. You have a fidget toy for waiting? There you go. You're thinking of using some sort of tinfoil tape to level your underbed. Yes, you can. So here's the thing is you could take some tinfoil and just keep folding it up on itself to make thickness and use that to help um, level your bed. In fact, they're talking about using washers underneath, and they say to be very careful on what size washers you use so you don't damage that PEI or the polyamide bed surface. Well, here's the thing: you've got a screw, a um, what is it's a screw, a carbon fiber puck spacer, and then a washer, and then you got your lock nut underneath. I would put any spacers underneath the carbon fiber puck if you need to do that to raise or lower a corner here, because we're not using springs, we're rigid mounted. Um, at this point, you'd be drinking decaf. So this is my second coffee of the day, and it's half regular, half decaf. When Mrs. Dragon gets here, I'm going to have an extra large full test from Dunkin'. So, yeah. So anyhow, where were we at? So we did the PID tune. Now it talks about MPC in this manual here. I have nothing in my config for MPC underscore calibrate for the FISEC kit. So I'm just gonna ignore it. And what it looks like it's doing another PID process, but potentially kicking in these fans in the process, right? Um, Extruder rotation distance. Um, I did that off stream as well. And I'm hearing the garage door, which is right beneath me, going up. So Mrs. Dragon's here. New coffee soon. Your ender has springs, but the bed itself isn't flat. Yeah. And that's the thing, is you can get that deck somewhat, but yeah, that's the old way of doing it, is either pieces of Kapton tape in specific places to help level out the bed overall, or you can do pieces of aluminum foil. You had it flat at one point, but you crossed the head into the bed. Well, that sucks. So we did do the extruder rotation distance. I did that already. Z offset, I did this already as well. I'm sorry. Basically, it's interesting. It tells you to home the printer and dock the probe, which we've homed and then we docked. And then it wants you to run a park center macro. So if we come down here under our force moves, no, not force, motion, no, parking, here we go. We have park the bed, park center, park front low, which is kind of this area, park front, and park rear. If you do a park center, it kind of centers all the axes. Don't know why it just did that. Oh, because it's homing. There you go. Now you've parked in the center of the bed. Okay, the bed's centered and you're centered in that Z, so that gives you plenty of room. Now what it tells you to do is increase the Z offset a few times. So that means literally come up here and do your Z offset a couple of times. So, and it suggests using the largest one, so the 0.00, or excuse me, 0.05 or not 0.05. Isn't MPC something from Danger Clipper? It could be. It could be. I don't know. I've never heard of it. Inner beds are like the Rocky Mountains. That is true, unless you get a Mike 6 build plate, put a Canovo heater on that sucker, never had a problem. But then again, I was linear rail on the X, the Y, the Z, dual Z lead screws, Mike 6 bed, micro Swiss all metal hot end, Sherpa mini extruder, Penda probe. Yeah. Hey, Nick, how's it going? Yeah, the Mike 6 bed is going to be better than that thin PCB style. Yeah, it was an Ender frame. That was about it. Um, so it tells us to, and I'll go ahead and do this again. So we're going to just move our baby stepping up some. So we're 0.15 up. I will go to, we'll go a 0.2 up. Okay. And then what it's going to tell us to do is lower the tool head to 2 millimeter using the main tool head controls and then put a piece of paper underneath there. So we're at 92. So we need to drop. So we're going to drop to so we're at 2 millimeters. Okay. And now we need to start going a little bit slower. We are good there. So I'm going to drop one. I'm going to drop another full one. And that gets me fairly close. Like I said, I did this last night, so I should still be 0.2 off. Place a piece of paper and then start lowering the Z offset until you feel the nozzle scraping the paper. So this is where we come back to using the Z offset pieces, right? So we're at 0 and we need to keep going lower. So I'm going to use the bigger one. Still not scraping. Fairly close. Might have had a partially warm bed from doing the pid tune. Huh. All right, there we go. There it's grabbing. That's good. I just want it to start grabbing where I can't push or pull without anything. So now that that's done, we're going to save that. And it's going to ask if we want to save the config. We'll say yes. And that's going to save that into our config, and we have a new Z offset. Yeah, and quite honestly, Nick, at that point, I think they just had Scoville SV06s for like 170 bucks through like KB3D, West 3D. I don't even know if probably Fabrico if they're carrying Scoville as well. Everybody had Scovilles for real cheap. And that SV06 is basically like an Ender bed in a Prusa Mark III, Mark IV motion system. So that mentality I now have 6 FDM printers. Yeah. So there we go. Now it tells us to do a live adjust. So start printing a single layer, a single large flat layer, baby stepping the Z offset while printing to find a tune. We'll do that. We will get into that tonight. I promise you that. Okay. For now, what I'm going to do is we're going to look at the bed tramming. So the Z tilt procedure takes care of getting the gantry level with the bed, right? It doesn't matter if your bed's like this, the gantry will get like this, right? But preferably we want it nice, flat, and level. Now there's a procedure to get us a little bit better. and course tune, run a home tilt using the QD home tilt macro, and then generate a bed mesh. So we're going to come over here, pull down. We're going to do that quick draw home tilt. Homes it. Okay. And now we want to generate a bed mesh. There is a QD mesh here. It says heat bed attached probe home mesh detached probe. I'm just going to come up here. This is what I was doing last night. We're already homed, and I'm just going to hit calibrate. And this is going to generate a bed mesh for it. Just ordered the Kitty Plus 4, sent them a support ticket requesting the updated SSR right away because I don't want to burn down the house. Yep, I would either do that or get an Omron and one of those big heat sinks and do that. Because I know a couple of people that went through and put in the new SSR board, which is still a custom-made SSR board. Yeah, versus going with a good rated Omron. And I would do an Omron, or what is the other one, the Panasonics. I've got spares of the Omrons. Every time I get down to one, I order 3 or 4 from KB3D. So. Yeah, I put a. Oh, we're done. I was like, what happened? So we're done. Let me bring this full display here. So our range is 0.175. Okay. We're on the higher scale gradient, right? So we want to go over here to the higher scale. We did probed. We can look at meshed. Okay, yeah, that's great. We can throw our flat on there and see what flat looks like. Yeah, we got a little bit of a bend. Okay. Now here's the thing to be cognizant of. I hate that this is so twitchy. So anyhow, this is the X, this is the Y. But what I want to do is orientate this with the X facing me and the Y over here. Okay? Because once again, it's leveling side to side here. Right? Probably about this to this, where it's at. So 028, 037, pretty close. What I've been looking at is these first corners here. So that's Z negative 0.003. Now let me go to the back here. 0.037. So this back corner is a little bit higher than the front corner. Over here we're 0.023 negative and 0.062 negative. So once again, the fronts are a little bit higher than the backs, but overall we're fairly close. I mean, yeah. That other one. This one. 1 second, folks. By the way, Mrs. Dragon is here, so say hi, Mrs. Dragon.
Hello, everyone.
We'll just do that. Did they actually put a jelly in there?
Not.
Oh. Hey, what? Oh. A regular, yeah. Cool. All right. Everybody saying hi. So thank you. Appreciate it. It is Tuesday. Yes, yes, it is. Ooh, pecan pie. Who's having? Wait, hey, a taco? Yes, we got a taco. It's Taco Tuesday. Um, love the holiday food. Just the food, dude. Holidays can be so freaking crazy, and it was great. We went over to my parents' house. We had a simple meal. My dad started talking politics, and I did the whoop, got him off politics, and it was a great day. Great day. So, yeah. Yep. Thanks for the donuts. Um, so yeah, I'll tell you this. A 0.175, I'm fine with that. Can I play around with this? Yes. Is it going to continue to change? Yes. I'm just going to let it ride. It should be able to adjust for any of this right now. Um, I mean, it has the instructions in here. If you have issues and encounter deviances of 0.5 millimeter or larger, those most likely stem from the alignment twists of the rail cart mounts, meaning these plastic pieces down here. I will tell you this. I loosened these up, pressed down in the middle, retightened them, it got worse. Then I loosened them up and took my two 1, 2, 3 blocks, lined it up with the screw holes, sat it down there thinking, okay, that's going to help center it. Then I wound up like this. So it was all in the way that I tightened the screws, right? So I was like, okay, one in the front, one in the back, tighten the screws up, starting with the bottom ones before the top ones. And I'm here, I'm not going to chase this, right? You can chase this. I know that I've got a very, very nice bed mesh on the black box, right? But the black box is like a rigid mount kinematic bed on a whole bed carriage that moves up and down. This is fine. Anything less than 0.2 and your bed mesh is going to take care of it. You can um you can try it, but you can spend all kinds of time chasing it. So now if it looks something like this, yeah, we'll play around with it. This isn't that bad. I am not going to sit here and chase this around because it could be for various things. Okay, go feed George. It could be various things, and quite honestly, it could just be the way I bolted it on there because I didn't bolt it in a specific pattern or I tightened one screw up before all the others. It could be various things. I'm going to go with it and print. Once again, everything's going to move around on your printer as you start printing with it. This is a new build. It's never been printed on before. We're just now running it through some motions. It's got to break in and everything find its equilibrium, right? So I'm good. I'm going to run it the way it is. And then I'll come back and validate belt tensions and all that. I just want to get some printing out on it. So it's got a whole way of going through tramming it and doing it by eye. Now, if your bed looks like this, um, yeah, you want to fix that. That's a build issue right there, right? You got to fix that. It ain't coming back. It ain't, bed mesh ain't helping a 1.3 millimeter deviation between high and low. You got to fix that. But if you're getting one like this is a point. Oh, I got to get in here. That is a 0.087 millimeter deviation. And believe it or not, I'm even better than that on the black box. So if you've got a bed like that, your cherry, your mint, keep pressing on. Stop messing with it. fine tune. Yes, you can fine tune. You can do this. You can do that. Um, I'm I'm good where I'm at. Like I said, for now, I just want to print some and let it rock and roll. And yeah, this is it. The final results can be deceiving based on the color visualization and Zmax scale. Always observe the range value. A range between zero point 0.1 and zero point 0.2 will give good results. Note that the bed mesh is not to sample the very edge of the bed. Spike measurements can occur in these areas, and it's better to disconsider them when evaluating the flatness. That's true too. Closer you go to the edge of the bed, the further you are from the center of mass, and it can bend down a little bit. Abitus, why would someone want an LH Stinger bed slinger instead of a Core XY? Um, a printer is a printer. It doesn't matter what kinematic system it is. And I can tell you right now, there is nothing that this printer brings to the party that I don't have in all the other printers around me. At the end of the day, it is a motion system that pushes filament. That's it. No difference. Um, it's just a different collection of parts that does the same thing. It's a bed slinger, like a Prusa, like a Evo Tarantula, just like a Prusa Mini. Um, why do you want a uh, Trident or a zero G or a rat rig that lifts the bed versus a Boron 2.4 that lifts the gantry and keeps the bed still? At the end of the day, it moves in 3 axes and it pushes things. That's true, Nick. And I did get rid of the video, but this thing is crazy fast, speedy, capable. It can print pretty mad. Troubleshooting X tilt issues. The bed tilt is not satisfactory on the X axis, left to right. You might need to adjust the Z tilt point locations in the quick draw probe. It's possible that the points sampled for Z tilt are not ideal and in an area that is not flat. Yeah, they moved it more towards the center, but I did notice that it comes over more from the left than from the right. So I might move the right in just a bit, but that's something that I can do later on. Bed mesh calibration, home the printer, move the tool head manually to the bed origin left front. Compare the values to the reference X18 or Y X18 Y38 used here. If they differ, then add those offsets to the min max values below in the bed mesh section of the quick draw probe config. Run a bed mesh calibrate to test your configuration while holding your hand on the emergency stop. Update your slices bed mesh origin setting if needed. Described in the macro bed origin guide. So hold the printer and move the tool head manually to the bed origin left front. Hold the printer and move the tool head manually. Bed or like X0, Y0? Because I would just do G1, X0, Y0. Okay, so X18Y, okay, gotcha. So I want to go to X18Y38, which should be the bed 00 because of the offset for the probe. X18Y38. X18Y38. Must home axes. Fine. Um, okay, so all right, let me see. Yeah, bass singers can be crazy fast. And like I said, these curtain fans back here. So it's 5015s on each side for standard part cooling, and it's dual 9733s back here for skirt cooling. I mean, it's crazy. It covers the entire bed in a skirt cooling. In fact, I'm probably going to have to, actually, I need to still install this duct here. And what this does is it gets mounted on that back carriage tensioner. So I'm gonna have to raise it up and put heat set inserts in so I can install this with screws. But it's going to go in this orientation, and it's going to take the air that's hitting right behind um, the hot end and push it down so it's coming more at the nozzle and not at the heater block. And of course, I still have the hot sock off because this is my reminder that I have to hot tighten that nozzle still, and we still need to do our input shaping. So I don't want to hot tighten the nozzle just because I'm going to have to take it off because it uses a nozzle probe. Okay, so we went here, and it at X18Y38, we should be at bed 0, and I'm going to say we're pretty close. Let me go ahead and lower this some. We're at 12.006. So if I drop this down 10, I'm going to hit that dock. If I drop that down 10, let me bring you guys in here and let's see how close we are to actually bring this up bigger. So how close are we to 00? Maybe a millimeter or two. Maybe a millimeter or two to the right. We come and look this way. I'd say based on that, if I can get a good angle under, here we go. I'd say we're spot on to the front of the bed there. So on X, we're a millimeter or two to the right. Should I be worried about that? Probably not. But I'm going to go ahead and raise back up that 10 millimeters and stick that back on. So we should be 00, and I think we're like 2 millimeters to the right, so we could probably change X to 16. And it says to make that change, they differ, then add those offsets to the min-max XY values used in the bed mesh section of the quick draw probe config. Okay. quick draw probe config. Said bed mesh. Bed mesh min. It's at 25. We'd want to change that to 2345. Yeah. Change. What is today? 3 December 24. And I'm going to leave this the same. Yeah, that should be. Hey, T Moore, how's it going? Hey, Bearded Printer, welcome on in. Yeah, the only thing with multi-axis, like more than 3, so if you do a 4th, 5th, or however many axes, the limiting factor isn't mechanics, it's slicing and how to do the slicing. Okay, so I think we did that. Update your slices, bed mesh origin setting. Actually, you know what? It's 2 millimeter, and I'm not going to ever be trying to go to the very corner. I'm good with that. Here we go. For safety reasons, it is recommended to patch the screw holes with some squares of Kapton tape. Okay. I don't know why. I I haven't needed to. Bed meshing works. It doesn't hit the holes. It gets close, but it doesn't touch at the holes. Resonance testing. To streamline your resonance testing process, it's recommended you utilize ResHelper. ResHelper Excel per Hertz branch is available, allowing dynamic adjustment of the acceleration per Hertz value during testing, without the need to modify configurations or restart Clipper. I believe we did install all those helpers already. When setting up resonance testing, is to gather accurate, repeatable data. One crucial parameter to tune is the Excel per Hertz, which determines the intensity of vibrations during testing. This adjustment helps elevate the resonating peak above the noise floor level. We'll go this way. Revealing the system's true resonant frequency. Typically, stiffer or heavier systems require higher excitation to generate a peak resonant frequency. Initial values in the LH Stinger configuration, ADXL Pico config, serve as a good starting point, calibrated based on empirical testing, considering the weight and stiffness of each axis. Ensure You comment, uncomment the relevant code section based on the axis under measurement. Okay. Peak intensity is not achieved. Increment the Excel per Hertz value by 10. Monitor the peak progression. Once stable data is obtained and no significant differences are observed, with further increments, consider reducing the value while monitoring the vibration percentage of the ZV curve. Find a sweet spot where measurements are ideal and vibration block. Okay. So we want to run the steppers in stepper fast CFG configuration mode. So this ensures that torque is not a bottleneck when it comes to overcoming issues such as binding. Note that the final input shaper values should be measured and set according to the settings used respectively. Steppers config and steppers fast config. Increasing stepper motor current torque also results in an increase of peak resonant frequency. If you have issues triggering resonances in the 1E5 scale range, even after increasing accels per hertz into the 180 to 220 range, try increasing the tension of the Y belt to 120 hertz and resyncing the steppers. Ooh. All right, this is going to be crazy. Okay, so a lot of things there. Uh-oh, what did I miss? All right, I was trying to read this wall of text here. Hey, Bearded Printer, welcome on in. Daldell, welcome in. Timor, welcome. Yeah, so for this, once again, I'm going to turn the printer because I want all of the feet supporting, weight supporting surfaces to be fully on this work surface here. And we are. What I also want to do is for right now, I want to go back to that park center. Okay. And we're going to need to set up our ADXL probe. So our ADXL probe is going to go on our nozzle. I don't know if I'll have enough room for my nozzle wrench. We'll see. This is a 1.4 Newton meter torque wrench. Yep, I'm going to have to raise this up some more. Go. And I grabbed the wrong size. Of course I did. Of course I did. Oh, that's awesome. Hold the nozzle and the whatchamacallit, the high flow extender out. And that's probably not a bad thing. So by the way, like I said, I did put some filament through here. So I just put some white PLA through here to do the testing. So there's some white PLA that came out of the heat break with the nozzle. We're going to need to get our nozzle probe installed. Now this is the sled that we'll use for the y-axis. I don't know how this thing gets mounted. If anybody knows, let me know. I don't know how it gets mounted. And I dropped the probe. And it's very critical to look at where your X, Y, and Z is. So X is this way, Y is this way. So when we mount this, we want the X to be going that way. So our plug's going to be coming out directly towards us. And because this extension is a 6mm thread as well as the nozzle, I'm going to mount it here where it's going to be even closer to the heat block and the center of mass. That works. Should work. Let me see. As long as I'm not going to crunch any chips on the board against the heat block, that will be perfect. If not, doesn't look like I will have an issue tightening this up. Yeah, I'll have to take the hot end out. So we'll grab some Nippics. We'll have to hold one piece while we undo the other, and hopefully we don't have an issue with the filament being in there. That would suck having to. Nope, not at all. Hey, shrimp father. Good God already, come on out. And as I stated, I have not fully heat tightened anything in here yet. And I haven't put the hot sock on simply because I know that I'm going to be hot tightening some things. So no sense in causing us any problems. And I'm going to snip this off flush with the back of the nozzle. That'll be easier to get back in. So now we're going to hang this directly on the nozzle there. We'll just go ahead and put our nozzle back in. And I am going to torque the nozzle down on the board. Once again, trying to keep that board nice and straight. That's going to make sure it's nice and secure as well. Okay. And this is going to get connected with a USB cable. Goes that way. Just a tight fit connector, basically. There we go. And this end will come over and plug into our electronics box. So let me get that installed. We should be able to just lift up the electronics box. We want to bring this in through the side. There is a hole on the side of our electronics box in the back. And we'll plug this into our Raspberry Pi. We can close our electronics box back down again. That way we can keep our electronics nice and cool. Okay. Now we have that installed. I don't know. Hopefully the macro installed everything it needs. I do have a light on the front of my thing here, of my probe. The initial values in the ADXL Pico config serve as a good starting point, calibrated based on empirical testing. Ensure to comment, uncomment the relevant code section based on the axis under measurement. Okay, so we are using Res Helper, so let's take a look at that Res Helper link and see what it tells us. Hopefully there's documentation in here. Series of scripts designed to streamline Clipper's resonance testing. That would be nice. Auto generates the resonance graph, outputs the graph images to the config folder. These can be viewed directly in Mainsail Fluid. Ports Excel versus per hertz. Yes, yes. Install. Like I said, we did that. Run the resonance test macro by clicking on the drop down arrow next to the macro button. You can define the following settings. Okay. Install per hertz defines the intensity of the testing position or motion of your graphs. Measures below a 1E5. If your graph measures below a 1E5 scale, it is then recommended to increase until you're above it. Okay, so we'll come down here. And resonance, we do have resonance test X. We are set up for X. So we'll click that down arrow. Excel per hertz, it's going to look at your configuration or config file setup, min frequency, max frequency, damping ratio, classic. I'm going to just run it and see what it does. And then we'll play around with some other things because I'm not sure if I need to come in and change anything. And well, let's take a quick gander there before. Machine, ADXL. I don't have an ADXL Pico, I just have ADXL. Excel per hertz is 80. Using an ADXL 1345, probe points. Min max. Okay, so X settings are commented out to start with. When we go to do Y, we'll just have to comment these and then uncomment those. Okay, good. So it looks like we're set to do this. So I'm going to click send and go. Okay, did I click send? Looking for something specific? Okay, what's it throwing? Oh, yeah, that's the other thing we might want to do. Printer config. We'll undo that ADXL config so it might actually be able to read it. That'll probably help. Use one or the other. We'll start off with just steppers, and if we can't hit the right things, then we'll go to the other one. Now the question is will it let me? Oh yeah. Got freaking tap. Let's go. It's not tap. It's my ADXL sensor. Hey, Liz. So okay, the only thing I did was uncomment the ADXL config. And now it's not talking. Let me take a look at this again. Oh, ADXL USB. Do that might be it, huh? Let's go into putty. 231, 231. I Raspberry. Now let's do an LSUSB. Hey, look, we got a couple of things. That's good. At least one more thing. Now we need to do that command. Now let's see if that works out better for us. MCU protocol area. This is frequently caused by running an older version of the firmware on the MCU. Ah. Oh, crap. So really, you're going to make me flash this? Oh, the machine you just got. Why would it have tap on a? It should not have tap on a switch wire. Once again, should not have tap on a switch wire. Crap. Now I got to figure out what. What. What am I thinking of? What sensor does this thing have in it? That's actually there. All right, so we're gonna have to do a few things here because we're gonna have to update our um, nozzle or our input shaper. So CD into clipper. And I'm just following the guide here. So we're going to enable low-level config options. It's a STEM 32. Um, F042. F042. No bootloader. Clock reference is internal clock. Communications is USB PA9, PA10. Optional features to reduce code size. Port GPIO bit banging, port LCD devices, unchecked. External sensor devices, checked. That one unchecked. Eddy current checked. Port E chips. Port software based I2C bit banging. Okay. That looks to match. To leave that menu. Yes. Copy that. That. An ender wire, but still, once again, an ender wire with tap. You're not supposed to put tap on an ender wire because the bed's not rigid mount. I don't know if it'll work decently or not, but oh, we got an ad break going on. So we want to run the following command. Let's see, ensure you're still connected via SSH. If not, reconnect. Connect the board to the host Raspberry Pi. While plugging the board in, you must ensure the boot button is pressed down. Really? Which one's boot and which one is... Oh, I guess there's only one button. So, how's that going to work? I think the easiest way is going to be to unplug it on this side. Hold down the boot button. Plug it back in. Let go of the boot button. And LSUSB. Do we have something in a, yes, we have a device in DFU mode. Hey, Shenanigans, how's it going? I should probably put that camera on instead. Hey, guys. So we've got it in DFU mode. We're going to run the following command to flash your NIS. Place that with that. Okay. So we'll do make flash, flash device. Grab this ID information right there. And hit the button. It's making the flash. And no such file or directory. DVR dude. Front row. So it did a flash error. I never saw a download, so it didn't successfully flash. So we're back to no such file or directory. LSUSB. It still shows that this is in DFU mode. And that should be the exact command. Make flash device 0483 DF11. Got the pets on rockets printing, but free 50 millimeter rail I can put on something else. That's true. Well, you can take the whole thing off and just replace that tap with the conventional one. And what you do is you take the tap off and you put the tap on something else. And then you put a eddy probe on. By the way, these are I've been doing some of these. This is Galaxy PLA, Bamboo Galaxy PLA, I believe, which is an interesting color. It's not a black, but it comes out well. And these will be like door hangers, or you can stand them up on a plate stand at your house. And I've done some of these and some white background or red background with white. How's that? No, white with red Santa Claus that I'm going to send to my mom-in-law so that the ladies or actually everybody on her floor can have things to hang up on their doors. So, yeah. So we tried to do the flash because it knows the make. It cannot open that. AVR dude done. Thank you. And it's not flashing. So what is going on? Compiled the firmware. As they stated. Oh, that might be. Yeah, I think there may, let me go back in here. There may be a few things that we have. We're still in Clipper. We'll copy this again. Made clean. We are going to come in here again. Once again, we're Enable low level SIM32 and F402. No bootloader. Internal clock. USB on PA9, PA10. Optional features to reduce code size. The only thing we want is support GPIO, external sensor devices. Don't need that. Bitbang, external sensor devices, and SPI Bitbang. Okay, there we go. Just need those 3 clicks. Yes. Okay. Hey, Superhope. Is that Ho or HC? Welcome on in. Thank you for the follow. And thank you, Liz. I thought it was kind of pretty. So we're going to make the config again. We're going to try and flash Clipper over USB. We should still be in DFU mode. Verify that by doing an LSUSB. Device is still in DFU mode, right? And it's 0483:DF11. That's pretty much the standard. So we're going to run this command to make flash and then try and flash the device. And it took an error, compilation terminated. Why is compilation terminated? It made it before. Made config there before. You know what? Let me do this. Make clean. It's trying to do a flash, but it wasn't making the file. I think there's something wrong here because we're telling it to make flash, right? Or, make kconfig config.nis. But then we're telling it to just do a make flash, but we're not giving it the file. And it's not actually talking to the board. Yeah, I just did a make clean and then redid it. So we're in Clipper. We'll do it. See, this is the thing. It's make clean kconfig underscore config equals config.nis, right? So we'll clear this. So we clean that. I'm also just going to do a straight make clean. So everything should be cleaned. Okay. We're going to go into here. And we've now got this configured with all the right things up there and the optional features to reduce code size. We only have 3 things checked: the support GPIO bit banging devices, support external sensor devices, and support software-based SPI bit banging, which yep, that looks good. So Q there. Don't need to do yes because none of that changed. Run make to compile the firmware. We're going to make kconfig equals config.nis-j4. Copy that. We're going to run that. Where does it put the output file when it does it? Creating hex file out clipper.bin. Okay. So it did do a standard clipper bin. Still connected via SSH. Connect the board to the Raspberry Pi host via USB and hit boot, which we did. We do an LS USB. And we have a SIM board in DFU mode. The only one that's in DFU mode is this board. Yeah, need to specify file and USB address. Make flash in the out folder. We've got the device in DFU mode. Yeah, so we need to actually go into CD out. And then run this command. No rule to make target flash now. Ah. So if we come back out to Clipper, so it doesn't run if we're in out. Yeah, we're in the Clipper folder. We run it. Right? We're going to make flash device. We're going to run the flash command, which is going to take the clipper.bin file that's in the out folder, and it's going to flash the device that we're telling it, which is the only device that's in a DFU mode, 0483DF11. So we run that. It does the make, and now this is going to start crapping out because it's trying to do a make, and it can't because there's already stuff there. So if I do a make clean, and tell it to do it, it's going to run that again. So the issue is it's not talking to the, it's like there's no bootloader. Do I need to tell it like a clipper.bin? Yeah, something's wrong here. Hey, look, there's a lot of issues with people updating from a Raspberry Pi. Make clean, make menu config, make flash device. Yeah, that makes sense. How about we just do that? And we're in Clipper. Make clean. We're just going to stop doing that nis whatever. Though that does give us a chance to do something else. But let's do make menu config, enable extra low level, stem 32, F042. F042. Um, I think I do have Kaya on here, but hold on a second. Bootloader offset is no bootloader. Clock is internal clock. USB interface is PA910. Optional features. Okay. We want port GPIO bitbang. We want external sensor devices. And we want software SPI bitbang. Okay. You? Yes. Okay. Now we just want to do we did a make clean, we did make menu config. We want to do the make flash now. What do we do? What do we do? Where did I go to? Yeah, make the make flash device. So installing Twitch. Yeah, these sort of hassles is why I normally install Catapult first. Then you know it's going to load and enter DFU mode easier. You can try adding the make flash command, the erase equals true. Well, I'm going to give it this one shot. So we basically what we're doing is we're just going back and doing a standard Clipper thing instead of doing that weird thing that they were doing. Sudo password for Pi, that's a new one. But hey, it's downloading. So that's good. Now if I do LS USB, there should be 4 devices and nothing is in wonky mode. So that's good. Um, Now that was painful. MCU protocol error, blah, blah, blah. We're going to do a firmware restart. Hey, look, we've got an MCU and an MCU ADXL USB there. Awesome. Now that we've done all that, how much you want to bet is it going to make me do a must home the axes first? Damn it. Okay. Okay, let's do I don't think we'll have an issue with the probe. It doesn't make it too much longer. Or yeah, we'll be fine. Okay, now let's docked. Let's do vibration test X. Going to move over, center itself, and it should start shaking. That was painful. Yeah, my bad. We'd already gotten the ID for it. All right, now it's cranking up and humming. Yes. Nope, it's not going to pick up the humming. Like I said, I know that it'll get mounted on this, but I don't know how this gets mounted. I'm sorry. It gets mounted to this piece to do the y-axis, but I don't know how it gets at, how this gets mounted to the y-axis um, to run the test. Okay, so we've got a input shaper. Let's see what it shows us. It should go up here in our machine. Should be a res data folder and shape for X. Boom. Okay, and we are in a 25 range. CV is the recommended shaper. 32,300 is the acceleration. Okay. Wow. Yeah, I don't know DaVinci. It's really weird. And This board was the first board that I have ever, this board being the spider board for this build, is the first time I have ever um, flashed a board using Kaya. I just have never done it. I've always done it by hand. But I, okay, this is the, you guys know, this is the first time I've run this. Wow. I think that's even a better input shaper graph than I got on the rat rig. And some more, you said hot glue to the PEI was how a client did it. I mean, that's one way. I mean, they have a print file. It would be in it, the file. So let me go over here. So it's a printed file. The printed file has these little divot things on them. You would think that there is something that's used to clamp this onto the board or something. Like, I don't know why, because doing hot glue might work, but yeah. As resonance results. I mean, what do you guys think? One, I think that's killer because we did get into the 1E5 range, and 32,000 Excel at 91 hertz is pretty darn good. That was the odd thing you saw done. Yeah, I'm like that's a new one to me. I just have no idea. I have no idea how this would be mounted to the bed. So what are we looking at? It'd be great if I could click on these and make them bigger. So their sample graphs were at 89.2 hertz with a vibration of 0.8%, SM 0.03, Excel 31,000. I mean, this was theirs, and this is ours. I kind of think we're pretty damn good there on the X. So if it's good, run it. Hot glue works every time. Oh, you're not seeing the screen. I'm sorry. So, these are the ones that they did in the guide, right? Aim for graphs displaying peaks around the following values: x-axis PSD around greater than 8 on a 1E4 scale. This hits a 1E5 scale, and around 0.8, right? And this was mine. We're at 1E5 scale up here in the 3 range for power spectral density. We have this nice crisp peak here and vibration 0.8%, SM 0.02, and acceleration of 32.3. And that's one of the best spikes and things that I've seen to date. So I think I think we're good there. I think we're good there. Um, now we'll need to do the Y, and like I said, I have absolutely no idea how I'm going to set this up to do the Y. But I do know that I'm going to have to undo my nozzle probe. So put that down there. We'll go ahead and put this back in. All right, so that's cold tightened down to 1.4 Newton meters. And the way this goes in is it's kind of clips in there. It's pretty tight to start with, but then you do want to put a nozzle in here to hold it down in that printed part. And I have a couple nozzles, so I'll just grab a different nozzle and put it in there for now. See, what do we have here? Unmarked. Always a good starting point. 0.6 West 3D, so this is a 0.6 Undertaker that I'm going to use as a, just a holding to hold this down. Seriously? Oh, of course. Going into printed threads, and it's like no bueno. Yeah. Ugh. Figure if I can get the nozzle down in there and cut good threads, then I'll be able to take it back out and do it with the board in place. How's it going, Adam? So we just did our first input shaper on the LH Stinger. And we did the x-axis first because, well, it was easier to do. And yeah, let's just go with it was sweet. I'll pull it up here and show you once we can figure out how to do our y-axis. Okay, so that's nice and solid there. And quite honestly, I might just Kapton tape it there. What do you guys think about that? Kapton tape it right in the middle of the bed? We got plenty of Kapton tape. In fact, I'm not even going to use theirs. I'll grab mine because it's already been opened. I think Kapton tape would work fairly well on it. What we do is we have a printed part, but we don't have, there's like no way described on how to get said printed part secured to the y-axis for running input shaper. So I'm going to, I want to try and keep it as straight as possible. We'll have a little bit, but it's not doing major vibration shifts. But we'll see. Oh yeah, Pezlis for partner. Thank you for doing that, Da Vinci. I'll agree. So we've got it sort of quasi maybe held down. Like I said, we've my Kapton tape. You're not going to print on it like that. You can make it really smooth, but we're going to see. We'll see. The worst we can do is run a input shaper and it comes up like crap, and we figure out a different way, right? So we're centered already. I and damping ratio. Question is do we need to grab any of this information and put it in the other file before we go too far here? Um, we need shaper frequency, shaper type, and the dampening ratio. And we're going to put that in the printer config file. So frequency is 91 hertz because we're doing ZV. So 91 hertz ZV. Printer config. Is there any input shaper in here? No, we do not have input shaper in here. Why not? Why not? Okay. Grab that. It was 91.0 and Z Victor. Okay. We'll have to update that information. We've got our thing down. Hey, West One, how's it going? And we're going to try and run the resonant test Y. Ooh. I almost did it, didn't I? We need to go into our ADXL and we need to comment out the X settings. And uncomment the Y settings. And I think we can just save this. I don't think we have to do a restart. I hope. Because that'll suck. Because then I'll have to peel this back up and do another home. Must home access first. Darn it. Okay. Peel up our captain and our ADXL. We'll have to run a home. And at this point, I'm just going to go ahead and do a firmware restart to make sure we're good on those changes we made to the ADXL. We'll do a PD home tilt. How's it going, sis? Thawing out, but all are fed and watered at the farm. Well, that's good. Now the question is did you feed and water yourself? Because you know you're a critical animal on the farm as well. Okay, we're going to dock. And I'm going to say Park Center. I'm going to take this, set it down here. I'm going to try and get it as centered as possible on the bed. Okay, so once again, it's going to do rapid vibrations. It's not going to do a lot of movement. So we should be good just taping it down, but we'll see what our results look like. So we're going to tell it to go ahead and start this resonance test. Woo, that scared the crap out of me. I'll show you what I mean by scared the crap out of me. We're on this camera. The nozzle was way up here. It dropped way down there. And that probe is, that was close. That scared me. But it's shaking away. Need another super light and stretchy hose. The barn hydrant was the only faucet not frozen. Uh-oh. Yeah, Mrs. Dragon went and got those, yeah, like flex hoses or whatever. The standard garden hoses aren't for, I'll say aren't for crap, but Okay. Switching coffee and grabbing a donut hole because we need our munchkins. Munchkin. Hey, Wilco. This is an LH Stinger. Hey, Mini Bice. Westbury is in Kentucky. And it just shut down. So that's interesting. MCU shut down, timer too close. Occurs when the controller is overloaded. Are you kidding me? It was writing out the data. Oh my God. So we have a CSV file, but no graph now. So we'll pull that up because we're going to have to rehome because we just did a firmware restart. What I'm going to do is I'm going to do a full reboot of the system now. Yeah, it shouldn't have been it's a belted Z bed slinger. Yep. Looks to have tons of cooling. That is definitely true. So at the tool head, it has a 50-15 fan on either side of the tool head for primary part cooling with 97-33 dual fans in the back for skirt cooling. This thing can do some crazy cooling. Cannot update MCU as it was shut down. Which MCU was shut down? There we go. So, yeah, we should be able to come out here and there's no resonant data over here. I'll do a refresh just to double check. But we're going to try this again. And I just want you guys to see. This was my input shaper on X. So this is by far and beyond the best. Did you set restart method command for the ADXL MCU? I did not because it was a yeah, it is not in there by default. We'll grab this. Good shout out, good call out. Okay, so we're going to need to rehome the printer. Kind of doesn't give you too much here, but because of the placement, I'm trying to put it so there's 2 feet on the front and the back on the Y rail here, and then each upright has a foot on it. So that's why it's sitting in this I'll say configuration. Do that. We'll do park center. We'll try not to freak out when it drops it all the way down towards the bed in a minute. So I'm just trying to get this centered on the bed. And tape both sides down, trying to keep it as parallel along the measuring axis as possible. Feels like it lifted it up so it's not flat down on the bed. Okay. Now we're going to try that again. We're going to do the next test. Scares me when it does that. Yeah, like I said, I didn't check that because this is the pre-built config. So, like I said, that was a good call out. So thank you. And yeah, that message is highly misleading. It could be literally anything. So I can tell you on the graph that we did for the x-axis, the acceleration was 32,300 at 91 hertz. So this thing has been going at, what was it? It was 30,000 acceleration. I think 1,000 or yeah, 1,000 millimeters per second or something like that. It was some crazy number. Um, Come on, baby, finishing right out appropriately. I do not plan on driving it that fast just yet, but and same thing. As it's trying to write it out, it craps out. So I don't know what that's about. And why it didn't do it on the X, but it's doing it on the Y. So we've got the data file. Can we go through and it'll benefit from Danger Clipper? Well, maybe I'll do a Danger Clipper upgrade on this. Disk errors over. See, the thing that's worrying me is it's triggering during the write. So I wonder if there's something wrong with the SD card in the Raspberry Pi. Um, bum, 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 bum. Pi and Raspberry. Let's see. CD temp ls. And the good news is we do have the Y resonance information here. It's a Raspberry Pi 4 swapped to a SATA SSD and Profit. Um, yeah, it is a, pretty sure it's a Raspberry Pi 4B. Aren't you? Yeah, it's a Pi 4 Model B. Um, there is a way to take this CSV file and still generate the input shaper graph the old way, right? Flashing this. This is the res helper. No issues or pull requests here. That's good to know. Um, Measuring resonances. There we go. Thank you, Mr. Wizix. So I do need to change this to Y instead of X for both of these. Resonance Y splat CSV, temp calibrate Y PNG. Okay, and where are we putting that? We're putting it into, man, what is that directory? Path slash config. Okay, so it's um copy. Paper. To is it Clipper config? The hell is that folder? I don't think that's right, but yeah. Yeah, that's not the right. The hell? Oh, I know why. Duh. Printer data. Printer data config. That's where I need to go. Res data. Okay. I need this path. cd temp ls. Copy shaper to. Oh, come on. That directory. Slash. Shaper calibrate. Underscore y dot png. Yay! Now I don't get all the pretty information, but we can look at this. Okay, so y, we're getting a 1E4, 102 hertz, 41,200 Excel. Interesting. Recommending MZV, and we've got a couple of more spikes, and you guys can't see what I'm looking at. Okay, so this is the input shaper graph that we're seeing. I don't know how much of it is being generated because we've just taped the accelerometer down, and how much could be just the tensioning of the belt. I can tell you the belt feels loose because the Y belt's supposed to be a little bit tighter than the X belt, and it's not. I think I can go a little bit tighter on this Y. Yeah, and that's a vibration of 4.7. So yeah, that's telling me that I need to tighten that belt up some. Once again, this is what they're looking for on, well, this is what they've got on their Y, 118 hertz, 0.8 on the vibration, 0.2 on the SM, 54,000. So I think what I've got to do here is tighten my belts up. On the y-axis, which is going to make it so I need to, yeah, I'm going to have to do some work to tighten that belt up. Not all that easy, and I may wind up taking the bed off to do it because it's so much easier to get to and tighten things up without the bed on there. So 8:30. Do not wrap up on yourself. Where'd you go? That way. Okay, good. I'm going to set that right there. The best way to do this. Will this go up? No? Why not? Yeah, because I'm not sure if I'll be able to easily do this without um words on stream. Hard sometimes. Shepherd driver warning. OTPW flag set. Shepherd driver Y has triggered the OTPW flag and may stop working if it gets any hotter. This is an indication of an over temperature condition. Huh. That's interesting. I wonder if maybe that could have been causing our other thing. Anyhow, anyhow. Reading hot here. I was getting hot and the MCU was getting, well, hotter. That's the step stick, not the motor. I presume it's a 2209. No, on the Y, it's a 5160. And my cooling fans are running. Which way are they running? Sucking air in and going over the top. What do I want to do? We're going to set this underneath here. Because if that underneath there, it will help me identify the right spot for my Allen key. And what I'm feeling here is this pretty darn tight on these screws, which kind of makes me think that what I need to do is actually tighten the belt up another tooth on the thing, which means taking the bed off, which is kind of where I was going with. I might have to take the bed off. So fun times, which means I'll have to do some re-leveling of the bed. And hopefully I won't have to go digging for lost screws. Or not screws, but washers. And what I'm going to do is I'm going to shut this down and disconnect some things. Shut that down, we'll disconnect some wires. Just because it's going to be safer to have these out of the way. Yeah, so I use 5160s on my, darn it. I use 5160s on the VZBot and on the Annex Engineering K3. The VZBot uses external drivers and they have I think a 3010 or a 4010 over the top of each driver. So I get you there. The K3 is using 5160s on a Constellation Supernova board. And God, there we go. And it's definitely pretty good on there, I'll say. Or as far as cooling goes, they all are cooling very well. So, dang it. And when I did this the first time, I didn't have uh, the aux fans on here, so it makes it a lot easier. And of course, this back one is a little bit longer and it has the bed wires attached to it as well for strain relief. So that makes it a little more awkward when we do this. Okay. Let's set that up there as well. Now that we have access to this, and of course I just knocked things everywhere, which is what I didn't want to do. because one of them's now down here. Other one goes. Yeah, it's this interesting little stack that we need to deal with. And this, by the way, has a 60/20. One set right over the, one is set over the 2209s and one is set over the 5160s. So what I need to do is try and get this one more tooth. Of course, those didn't drop down on there either. He's back out. Sorry, I'm not paying attention to the screen as much. This is a little bit fiddly, and I need to pay attention to what I'm doing so I don't mess something up here. Still feels like it's not right. That may have been part of my problem is I just did that with the um, thing still tight, so this belt couldn't move any. Hey, 3D Medic Vince, how's it going? Yeah, I definitely know that having some additional cooling on tap for 5160 is definitely a good idea. Um, and I definitely work to keep some extra cooling for those because they do get hot, they do get toasty. You want to keep a um, fan on them. In fact, um, the VZ bot, Vez actually has a water cooling block set up for it. So you can water cool it, which is kind of crazy. Feels a bit overkill, but if you're trying to get every last ounce of performance out, you know, that's going to be the way to go. Oh my God. Okay, there. So how's it going, 3D Medic Vince? Hope you're doing well. Now, one thing that I will say is um, there is a version of this plate that's like a PCB that's or an aluminum one that you can have made or purchase, and that would probably be a little more righteous because this could bend some. By righteous, I mean as far as trying to get really good belt tensions. This is definitely a lot tighter than it was. We shall have to see if we made it better or worse. Yeah, it's definitely tighter than it was. Um, we work on getting my stacks aligned back here, and we'll try and get our bed put back on. Okay. Now, that's on there. It'll be easier to set this up on its side. And at least get the um, nuts started, because you have to put a washer and then the nut. So we'll get the washer and the nut started, and then we'll work on doing the rest as far as tightening it up. And then of course, I'll have to go through and do the whole bed stuff again, which I will do off stream. I won't subject you guys to me doing all the bed kind of calibration stuff again. And once again, I'm just getting these started. I'm not tightening them all the way down. I'm just making sure that they're on there and they're not going to come off. So I hope everybody's doing well. What we're doing is we're simply trying to get um, our y-axis a little tighter, because our input shaping graphs were kind of dismal. So we wanted to tighten up our Y belt just a little bit to make it a little bit nicer on the graph, or see if we can get a little bit nicer on the graph, because we were a little bit low on the input shaper results that we got. And with me starting to put it on with it on its side like this, that's why I can't tighten it up right now, because if I go to tighten it up, it's kind of falling off to one side, and that will skew my bed flatness. So I'm just getting them started, and then I'll put it back upright so that the bed's laying flat. And then I'll tighten down each corner. Okay. Kind of let it find its center, because once again we're using whatchamacallit, countersunk screws. So I'm just going to go around and slowly tighten these up, and that'll let the screws kind of find their center. Kind of like how we tighten up our rails by doing them from the center out, or from one end all the way to the other end to prevent a bow. We kind of need to do the same thing here. Because these are countersunk screws, they'll find their center. We just need to make sure that we can help them along in finding their center. Just making sure that we're not pinching those wires there. Dang it. And yes, I know somebody's going to get me for not using a wrench for this, as far as holding the nuts. I know somebody's already called me out on that on one of my other streams. And when I say that, it was somebody that was watching my YouTube channel, not this. Okay, so bed's back on there. Nice and sturdy. We got our belt, should be a little bit better. So let me go ahead and get our cables back in there. And the nice thing with the Molex connectors here is our sensor and our steppers, which are two big long cables. They're slightly different. One's bigger than the other. I think one's 24 and one's 22. So they'll only go on one way and lock in. So that's good. we're back in play. Um, Now, what do we do? What do we do? What do we do? We go and do a bunch of stuff all over again. First off, we turn things on. Yeah, that's the nice thing is 3 plugs, and you have the machine is separated from the electronics. You don't have to worry about anything. So that's pretty nice. Not nearly as nice as a positron though, which all folds up and is all self-contained, but not too bad. Hey, look at that. We're up and running. Now, I know I'm going to have to home. Oh, let me think something. Bed stuff. What was that? Come back up here and see if there's anything Z offset. We might need to redo the Z offset. Okay, with the steppers disabled, move the bed backwards. With the steppers disabled, move the bed backwards. Does not feel disabled to me. Okay. Run the force set positive. Okay, that sounds to be good. Loosen up the grub screws and run the AW sync. AW sync macro. Go. That back up. We don't need to do a PID. We don't need to do that. Z offset may have changed. We'll have to see about that. Home, dock probe, Park Center. No trigger on dock after full movement. Okay. Well, that's not your full movement. Come on. In Park Center, we will go up a couple of notches. Grab our paper of reckoning. We'll drop ourselves down. And we're good. So we'll save config. Go home all. Alrighty. What do we want to do? Let's do a Z tilt. No, hold on. What do we want to do? Bed trimming, UDT home tilt, and then generate a bed mesh. All right, sounds good, Westery. Get some sleep, sis. Oh, damn. I guess it would have helped if I had actually used this the way it was supposed to be used, too. That would have helped tighten that belt up. Oh, well. We'll play with that again later. We'll see if our resonance got any better. And if not, then we'll mess with it. Oh, bed mesh. How are we doing with bed mesh? See what our bed mesh looks like here. 0.2, so it's off a little bit. X there, Y is there. So where are we at? We're at 3118, so high in the front. So high in the front on lower in the front on both sides. Let's see if we can't tweak the backs down a tad bit more. So we were at 296. Let's see if we got any better. All right, thanks for being here, Simar. We'll see if we got a little bit better here. If we did, great. If not, we may tweak it a little bit more. We'll see where we're at. But I do want to try and get another input shaper done on Y to see if we got a little bit better or not. .287, so barely what we did. Still high in the back, middle. Kinda weird. Negative 0.26, negative 0.25, negative 4.5, negative 6.3. Actually, I wonder. Kind of still goes way to the right a little bit, so I may change that mesh up just a bit because it's going pretty much right to the edge over here, which could be throwing some things off. Not that 2 millimeters is going to make a big hill of beans difference. Okay, so it actually got worse. Don't know why it's. Oh, so how are we doing? We are rerunning the bed mesh one more time. May need to do some different adjustments here, but like I said, I really want to check the um whatchamacallit. I want to check the Y resonance and see if we've made a difference there. All right, we're getting better. We're still high in the back. I don't know why we're so high in the back here versus the front. I don't know if maybe letting yeah, I don't know why we're tacoing. Don't know why we're tacoing so bad. Kind of feels like I can loosen this a little bit more. But let me home it again. I'll keep playing with the bed here in a minute, but I want to go back to the resonance testing. Over there, I want to park high so that it will kind of get out of the way and I can put my resonance tester back over here. Okay, so we've got that. We're going to do our resonance test Y. So it's drop down and it's going to start the resonance. Now we're going to see if it does that error out again, then I have a feeling it's something to do with the Raspberry Pi and possibly um, the SD card in it. But we'll see. Right now I'm kind of stepping back away and letting it do its thing. So Pez Liz, have you heard anything back on your partner push? Like, I guess, did you get any type of acknowledgement that you submitted? Because I have no idea how that works. Just curious to see if you got anything back from them whatsoever. I think we go to about 125 hertz. We're getting close now. And then I'll do its write out to the temp folder. Oh, we're going up to 135, 140. Yeah, just at 140, it started to do its write out and it dies. So it's when it's trying to do its write out that it's dying. And I don't know why. Like, we did get the CSV file, so that's good. So go ahead and do a firmware restart. And I need to start session, log in as Pi, Raspberry. And I need to make sure I understand what we did to transform that. PD to temp, less. Yep, we got a new Y resonance there. There we go. Clipper scripts, blah, 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 blah. Y to shaper, calibrate, Y. Date.png. Okay. Now we want to copy this to that. Machine res data, and there's our new Y. Let's see this graph. And this got all kinds of ugly. Wow. Okay, that got worse. That got big time worse. Okay, so I'm gonna have to work on that. Yeah, timing too close can be a pain to find the real source. Exactly. It's failing right as it's writing, and it didn't do that for the x-axis. So I don't know why it's doing it on the y-axis. The other thing that I will say is we're also doing this just by taping this down, so that could be skewing our results some. In fact, it probably is skewing our results some because it's not as
rigid as if it was bolted down. So I do want to see how people are doing that for the Y. I'll take a look. I'm probably also going to redo the Y belt tension one more time, which means taking the bed back off. But that's okay because I realized I missed a step. So it may not be as tight as I think it is. So but with that said, and we took a stepper driver warning, so this also happened. So it could be that the stepper driver for Y is heating up, and it would not be. None of the heat sinks are hot though. None of the heat sinks are hot. The front motor is warm compared to the other ones. And of course it's dropping back down. So yeah, I'll have to play around some. But I think that's where we're going to end the stream for the night, folks. I wish. Sorry. I wish I made it further. Um, I may play around with this a little bit more tonight, just to try and get the bed squared away again. But I do have to get up and go into the office tomorrow because I've got VPs in town. I should have went in today and I didn't. But the next, tomorrow we've got an all hands, I'll say offsite lunch, late dinner function, whatever. And then same thing on Friday. So I've got a bunch of different meetings and stuff that I have to attend. So it is what it is. Yeah, this is the way of doing a high-end, high-speed printer. This normally would not be that big of a deal if we were doing like an Ender, right? Be pretty easy. But we'll go ahead. We'll get this figured out. Not a big deal. Yeah, we'll get it figured out. But thanks everybody for being here. Let me see who we can raid out to. And I promise the next stream we will be pushing plastic. We will heat tighten that nozzle and we will be pushing plastic on the next stream come hell or high water. Let's see who's out there that we can raid into. We got Joe Mike Makes doing his slab dart blaster. Big Jano's online. Science is up. Declarations. Wow, a lot more people are up tonight. We normally go into Jano. Let's go over to Joe Mike Makes. See you later, Pez. So we're going to jump over to Joe Mike Makes. Once again, thank you everybody for being here. I appreciate you taking time out of your day and spending it with me, especially as we play around with these builds. So come back and see me on Thursday evening. We might run a little bit early again because I do have my Warrior Rising class Thursday, which means we might try and throw some extra time in there or do a really long stream Saturday to get this thing going. But thank you everybody for being here. Once again, yes, Pez Liz for partner. So take care everybody, and I will see you guys next time. Bye now. And for those of you watching YouTube, there will be a suggested video down in this corner. Bye now.